So this little chart could be helpful when we're looking at those two IXL lessons that we just did. That helps us just get used to making the number line graph to represent the inequality. So when we're working with inequalities, there's not just one number that's the solution. The solution is really a range of numbers. So as we look on here, we're going to see, wrong screen, all right. So when we are solving inequalities, we're going to have to try to get the variable by itself. That works very much like it does with an equal sign. There is one rule that we need to remember that is different, something extra. First off, we usually have the symbol instead of the equal sign. But there is an extra rule that when we are solving inequalities, the inequality symbol is going to flip. It's going to change direction if we multiply or divide by a negative number. Now, for some of you, you may, at this point in our class, you might just trust me and say, okay, if Carolyn says so, I believe it. But just to illustrate to you why this is necessary, let's look at some regular numbers. Just in case you're like, I guess if you say so, but. So let's say if I were to compare 4 and -3, which one is greater? 4. Everyone agrees with that, right? 4 is greater than -3. Well, what if I multiply both of those numbers by -2? So times -2 on both sides. You know, like when we're solving an equation, we might have to multiply both sides. Now the left side becomes -8, and the right side, +6. And which one is greater now? 6. So you see what happened there? The symbol, if I use the same symbol, it would no longer be true. So when we're solving an equation, we know that the x represents a number or numbers. So the same thing applies. So if we multiply or divide by a negative number, we're going to flip the sign. So do you all know the song, the children's song, If You're Happy and You Know It? Yes? Okay. So we're going to sing. You ready? If you're happy and you know it, clap your hands. If you're happy and you know it, clap your hands. If you're happy and you know it, then your face will surely show it. If you're happy and you know it, clap your hands. Now I'm going to sing a similar song to help you remember the rule. If you multiply or divide by a negative, flip the sign. If you multiply or divide by a negative, flip the sign. I'll sing my silly song so you don't get it wrong. If you multiply or divide by a negative, flip the sign. All right, so if, while you're working on these problems, I stop by your table and I tap my finger and say, Ratuja, do you really want me to sing? Then you will know, oh, I must have forgotten to flip my sign. So that will be my reminder. If I start acting like I'm warming up my singing voice, then you know, uh-oh, I forgot to flip my sign. So now, it does not happen every time we see a negative. So please, if I had something like this, 4x is greater than -12, I would divide both sides by 4. I would get a negative answer, but my sign does not need to flip. Because did I divide by a negative? What I did to both sides? No. These numbers are positive. So I don't need to flip. The negative just already lived there. Right? I did not divide, but in this example,
when I divide in the negative,
this number,
flip the,
yeah. So here, do you see the difference between the two examples? This one, this number that we are doing to both sides is negative.
It's not the same. The
So the one on the left, x is less than negative 3. The one on the right, x is greater than negative 3. So here we have an example. Subtract 5 on both sides. Divide by negative 3. So very much like what we would do with if it was an equal sign. But because we divide it by a negative, that x had a negative on it, the symbol changes to be greater than or equal to. And if you put your answer in the problem, it should be true. Like, then I'm going to get something that's going the right direction. Or choose something that's bigger than 7 to make sure it works. And then this is just a reminder of what you practiced on IXL. That the closed dot or closed circle goes with these two, and the open, you can refer to it as a dot or a circle, is when we don't have the line, and that x is greater and x is greater than or equal. These would both go this way. And x is less, or x is less than or equal, is going to go this way. But now what's going to happen is we're going to solve a problem and then decide how the number line graph would look after we solve the problem. So this is a nice two-step problem. What will my first step be?
6x is less than 15 plus 3.
So we're going to add the 3, right? Yep, we're going to add 3. So whether you like to write it in both places or you just move it over and make it plus 3 on the other side, that's what we're doing. We're adding 3. And then we'll divide by 6. So then our answer, less than 3. And then we make our number line graph. So will it be an open or a closed circle? Open circle at 3. And then our shading will go back to the left all the way to the arrow. So that's saying that all of those numbers that are shaded and continuing to the left, they would all be things that make this true. If I am uncertain, if I put my shading in the right place, if I choose one of these numbers, let's say I choose -5, and I do 6 times -5 minus 3, that answer should be less than 15. Well, that would be -30 minus -33. Is -33 less than 15? Yes. If I shaded in the wrong direction, that would not be true. Okay, so it should be, if I'm comparing two numbers, it should be pointing at the smaller number and open to the larger number. Much the same two types of steps, but it's going to have one extra thing that we have to do because of that starting out with -4x. But first step will still be subtract the 2. So now we have -4x and then 10 minus 2, which would be 8. And we still have greater than. And then our second step is going to be divide by -4. This negative kind of got a little bit far from that x, but yes, divide by -4. And because we divide it by a negative, the symbol is going to change. Oh, change direction. The symbol is, my finger wasn't on board yet. The symbol is going to change direction, and then this is also -2. By the way, if that had been a negative number on the right, we could have a positive answer and still have to flip the sign, because if we'd had to divide by a negative. So our solution is x is less than negative 2. So now negative 2 again gets an open circle because it does not have the or equal line. And then our shading is going to go back to the left. Less goes to the left. Now, maybe here I'm like, wow, I don't know, this kind of feels weird about changing it. Let me test something. So I would want to test something in my shaded area. Let's say I pick negative 5 again. So negative 4 times negative 5, I'm putting it back in the equation up, or the inequality up there. That would be 20 positive plus 2. Is 22 greater than 10? Is that true? 22 is greater than 10. Yes. So if I had not changed my sign, my symbol, I would have shaded the other way. And if I put in a positive number, the answer would have been negative, and that would not be greater than 10. So you do not have to, but if you're hesitant about if your shading is in the right section, you can plug a number in, any number that's in the shaded part, to see if your shading is in the right place. If you plug in the exact number, the negative 2, it's just telling you that your circle is in the right place. It's not telling you if your shading is in the right place or not. If you're working one of these problems and your answer does not appear on the number line, that's a red flag. Yes, you should go back and check things. Please keep in mind, like some of these, only every other number is on there. So for instance, for number 4, as I already mentioned, our symbol would change. So if I have this and I divide by negative 3 to get the r by itself, so I get negative 15, and the symbol changes direction because we did divide by a negative. And then I have an open circle at negative 15. Now, occasionally someone will ask me, but I don't see negative 15. Well, negative 15 is just this unmarked line between negative 14 and negative 16. Right? So it's to the left of negative 14. Right there between those two, and then our shading would be going to the right. So be careful, like those missing numbers, we're used to seeing 15 on the right side of 14, but because we're in the negatives, it's going to be going the opposite direction. So use all your clues around there to make sure you have it in the right spot. Sometimes people get them in the wrong place when it's on the negative side. Then we have some that are 2 steps. And then we even have some where maybe we need to distribute first. But your steps are still the same as they were when it was an equation. We just have that extra that if we multiply or divide by a negative, we'll change the sign, and then we're making the number line graph at the end. So for number 8, for example, I'm going to distribute. And for some of these, there may be other ways you could do the problem, but I think for most of us, we usually distribute first. Then I'm going to add 48. And then divide by 8. I did not divide by a negative, so I have no reason to change my sign. I just keep my same sign. And then, is this going to be an open or closed circle? Closed, good. And should I be shading to the left or to the right?
For 22.
Yes, toward the 22, to the right. Good.